In this video, we are going to discuss the statement of first derivative test for a function of single variable. It will lead us to locate and identify the critical points on the continuous curve. The statement of first derivative test is: consider a function of a single variable y is equal to f of x. Find its first derivative f dash x. To locate critical points on the curve, we place f dash x is equal to 0 and solve for x. Say the value of x is c. So firstly, if f dash x is greater than 0 for x less than c and f dash x is less than 0 for x greater than c, then x is point of maximum value. Secondly, if f dash x is less than 0 for x less than c and f dash x is greater than 0 for x greater than c, then x is point of minimum value. And lastly, if the sign of f dash x doesn't change as x varies from left to right of c, then x is point of inflection. Now we will discuss each of these concepts in detail. The first statement is: if f dash x is greater than 0 for x less than c and f dash x is less than 0 for x greater than c. Let's elaborate this concept. First, we must know what is the meaning of first derivative to be positive or negative. Uh, First derivative positive means f of x is increasing, and first derivative negative, that is less than 0, means f of x is decreasing. Now let's draw a certain portion of a curve. Suppose this point is x is equal to c. Now we check the behavior of this curve on left of c and on right of c. When x is less than c, the function we see that is increasing, that is its derivative is positive. So f dash x is positive when x is less than c. Now we go towards right of c and we see that the function is decreasing, that is the first derivative is less than 0. So the first derivative is less than 0 when x is greater than c. So x is equal to c is the point of maximum value. As we can see from the graph also that x is equal to c, the function has maximum value. Now we discuss the second point of the statement. Here f dash x is less than 0 for x less than c and f dash x is greater than 0 for x greater than c. Let's explain this by graph of a curve. We draw the graph of a certain portion of a curve. Suppose this point is x is equal to c. Now we investigate the behavior of curve before c and after c. Before c, we see that the function is decreasing, that is its first derivative is less than 0, and on right the function is increasing, that is its first derivative is positive. So we can say that f dash x is less than 0 when x is less than c and f dash x is greater than 0 when x is greater than c. So we can say that x is equal to c is point of minimum value. As we can see from the graph also that at x is equal to c, The value of a function is the minimum value. Now we discuss the last point of the statement of a first derivative test. Now we investigate what happens when the sign of first derivative does not change as x varies from left to right of point C. Let's explain it by a graph of a certain portion of a curve. We identify 2 points on these graphs and investigate the behavior of graph around these points. Let's let's first call this yellow ball as x is equal to C. Now we investigate what happens before x is equal to C and what happens after x is equal to C. Before x is equal to C, that is when x less than C, we see that function is decreasing. That is, its first derivative is less than 0. And when we go towards right of C, that is x is greater than C, we see that the function is again decreasing. That is, its first derivative is less than 0. So when x is equal to C, f dash x is less than 0. And when x is greater than C, f dash x is again less than 0. That is, the sign of first derivative doesn't change as we move from left to right of C. Therefore, x is equal to C is point of inflection. Now we call the second yellow ball as x is equal to C and investigate the behavior of curve before and after C. We see that before C, that is when x is less than C, function is increasing. That is, its first derivative is positive. And when we go towards the right of C, that is when x greater than C, we again see that function is increasing. That is, its first derivative is greater than 0. So, if x is less than C, f dash x is greater than 0, and when x is greater than C, f dash x is again greater than 0. That is, at this point, the sign of determinant, the sign of the first derivative of the function doesn't change. So this point is also point of inflection.